You are welcome to chemistry class with Christopher GK, your chemistry teacher, and today we'll be looking at a very important topic in chemistry titled Particulate Nature of Matter. Particulate nature of matter, that is the topic we'll be looking at today. And by the end of this particular class or video, you are expected to achieve some goal or some objectives. And they are, number one, you should have learned the physical and chemical change. We are going to look at physical and chemical changes. We are going to talk about atoms, molecules, ions, and atomicity. You should learn this. You will learn all this by the end of this particular video. Then the Dalton's atomic theory, we study the Dalton's atomic theory, 5 Dalton's atomic theory, and the modifications of this particular theory. Then constituents of atoms, protons, neutrons, and the electrons, things that have to do with atoms, we're going to look at them in this particular video. So follow suit and listen carefully. Let's run this class down. Now, we are going to follow them one after the other. We are going to follow them one after the other. First of all, let's begin with chemical change. Chemical and physical changes. Now, physical change is a type of change in which is easily reversible. It's a change that when it takes place is easily reversible, and in it, no new substance or substances are formed. Any change that when it happens, it is easily reversible, and actually no new substance is being formed, we call it physical change. Something like melting of solid to liquid. When you have an ice block, you can melt the ice from that solid to liquid. Nothing actually changes. It's the same water. Even freezing the liquid to solid is same water, and it can be revised. No new substance is formed on it. Vaporization of liquid to gases. Even when you are heating water, you see vapor. It will be evaporated. Some of them can condense. It can condense in the under the cover of the pot, or whichever way. But vaporization of liquid to gases, nothing. Liquefaction of gases to liquid, sublimation of solids to vapor, and even from that vapor to solid again. Something like camphor and iodine crystal, they undergo sublimation. But from that solids to gases and gases down to liquid, no new substance is actually formed. So such kind of changes, we see them around us, and we call them physical change because they just change the physical state, but nothing is actually being formed. So that is physical change. Then chemical change. What is chemical change? Because we see things change around us every time. Things change from one state to another. Chemical change is the one that is not easily reversible. When it undergoes changing, it can be reversed to the original change, and a new substance is also formed in the case. It's not easily reversible, and something new entirely is formed. We call it chemical change. And you know, it's most of all those things that we do in chemistry, we just need to understand it. That is what we do. That are the reactions that take place. Something like burning of substance. When you burn a wood, get a firewood and get it burnt, and once it's been burnt, you can't get that wood again. It's chemical change. It will turn to ashes, and ashes is a new substance entirely from wood, and it can be revised. Nothing will happen to it. We call it chemical change. Dissolution of metals and limestone in acid. When a metal is being dissolved in an acid, it can come back. It can come back to that metal again. Chemical decomposition, like digestion of foods. When you put your food, when you are eating gari, you are eating rice, you are eating anything you are eating, you put it, digestion starts from the mouth. From there, and all the digestions that will take place, it can go back again to that food again. And in fact, the end product of it, you see it from through your anus, and you see there, it's not that same food that you ate again that you can see there. So it's a chemical change. Rusting of iron, when you expose a metal to the atmosphere, after some time you see it rusting. The change that took place there cannot be revised again. Sharing of sugar, of course. The dissolution of metals in acid, of course, I talked about that before. These things are chemical change, and it can be revised. Something like when you sharing of sugar now, when you heat a sugar, of course, cube of sugar or even granular, when you heat it, I tell you, you will see something black on that white stuff, and it can't go back again. We say that the sugar has charred, or you can, when it's being added to acid, you can also see some changes. So sharing of sugar cannot return to its original change. We call that one chemical change. So those changes that cannot easily be revised, and new substance is entirely formed, we call it chemical change. All right, what are the differences between chemical change and physical change? So these changes are different. Physical change are easily reversible. Chemical change are not easily reversible. In physical change, no new substance is formed. Chemical change, new substance is definitely formed. In physical change, no change in mass, of course. In chemical change, there is a noticeable change in the mass of the new substance. Then in physical change, is not accomplished by heat change. But chemical change, of course, there must be heat change. Some of them are exothermic, some of them are endothermic. So heat change is always accompanied in chemical reactions or chemical change. Okay, that is it about chemical change and physical change. I hope you understood this particular one very well, because we see changes around us, and we need to understand the one that is physical and the one that is chemical. All right, now let's move to what is an atom, and molecules and ions. An atom is the smallest particle of an element which can take part in a chemical reaction. The smallest of anything that is capable of taking part in chemical reaction is what we call an atom. The atom is the basic fundamental unit of elements, and they are the units which are concerned in the chemical reactions. The smallest and the fundamental unit of elements, the buildup of elements, are atoms. The smallest units, the way we have smallest unit of life in biology are cell, the smallest unit of element, everything around us, we call it atom in chemistry. So an atom of oxygen is just, the symbol is O, atom of chlorine is Cl, atom of silver is Ag, atom of carbon is, the symbol is C. The smallest part of it is atom. So those atoms, those elements you see are made up of several atoms in it. A particular element is made up of several atoms. Molecule. Now, what is a molecule? A molecule is also a smallest particle of a substance that normally exists alone and can still retain the chemical properties of that substance, be it an element or a compound. Because some elements exist as molecules, they don't exist just as an atom. So the smallest way in which an element can exist alone on its own and retain the chemical property of that particular substance is what we call molecule. It could be an element, it could be a compound. So any compound is a molecule, but not every element is a molecule. Some elements exist as molecule, exist in molecular form, some exist as just an atom. So some molecules may be made up of some atoms of the same elements. Something like hydrogen does not just exist as hydrogen atom in nature. Hydrogen gas is hydrogen molecule, it exists as a molecule, H2. Oxygen does not just exist as an oxygen atom, naturally it exists as oxygen, O2. Oxygen gas, oxygen molecule. Chlorine, the same thing. phosphorus, the same thing, sulfur, the same thing, and many others. Whereas that is for elements, molecular elements, element that is made up of, or molecule that are made up of the same element. Now we still have, when we have different elements involved in a particular molecule, something like water. Water is a molecule, H2O is a molecule of water, H2O, but the different elements that makes it up. Something like hydrogen and oxygen is what makes up water that you drink, that any kind of water, whether pure water, spring water, drink water, all of them contains this formula. Methane, CH4 is a molecule. Ammonia is a molecule. Carbon dioxide is a molecule. All of them, but they're made up of different elements. So when you hear about molecule, it could be an element of the same formula, of the same element, of the same atom. It could be of different atoms. That means compound, but it's still a molecule. They are capable of, they exist alone and still retain the chemical properties of that particular element or compound. Okay, when you hear about atomicity, because we have talked about atom now, but we just talked about the molecule so that you will be able to understand what atom, difference between atom and molecule. When you hear about atomicity, what do you understand? Atomicity is the number of atoms in each molecule of an element. Now, it's a molecule, but the number of that atoms in that molecule is what we call atomicity. So hydrogen is H2, that means the atomicity is 2. Now oxygen is O2, the atomicity is 2. Ozone is O3, the same formula of oxygen, but it has three oxygen atoms. The atomicity is 3. Phosphorus is P4, the atomicity is 4. And down, so argon is, you can see, argon is just 1. It's just an element. Neon is an element, it's not a molecule. Get it? Now, neon is not a molecule. Argon is not a molecule. They are just atoms of, neon, atom of argon, but chlorine is molecule of chlorine. And atomicity is 2. Sulfur atomicity is 8. Neon is 1. Argon is 1. So that is what we mean by atomicity. If you ask the atomicity of a particular compound of element, just look at that particular element, know how many atoms of that element that are on it. That is the atomicity of that particular element. Okay. Now, what is not an ion? Ions. An ion is any atom or group of atoms. It could be an atom. It could be one atom. It could be group of atoms which possesses an electric charge. This one has charges. Ions has charges. Ions have charges. It could be positive charge. It could be negative charge. So some substances that are not built up of atoms or molecules, but are made up of charged particles are called ions. Hydrogen ion, H2, CO3, 2 minus, and all of that, carbon 2, H2SO4, when you break them, they form ions. So when you hear about ion, cation and anion, ion are a charged particle. Even elements can be ionic, which means sodium ion means sodium plus. Sodium ion meaning that it has given out 1 electron. It could be elements, it could be a group of elements. That's why we say is any atom or group of atoms, but it has charge. Electric charge means that it could be positive charge, it could be negative. Any element or group of elements that you see that carries positive or negative charge is what we call ions. Simple. That is what we call ions. Now, there are 2 types of ions. The positive charged ions are called cations, while the negatively charged ions are called anions. Example of positive charged ions are potassium ion, calcium ion, zinc ion, sodium ion, aluminum ion. All the metals are cations, while all the non-metals are anions. So negative charges are what we call anions. Ions made up of group of atoms are known as radicals. They are ions, so they are ions, but we give them the name radical because they are a group of atoms. Something like CO3 2 minus. That means triosocarbonate 4 ions. Triosocarbonate 4 ion. Then NO3 2 minus is also triosonitrate 5 is an ion. So ions of this one. Carbonate ion and nitrate ion, that is simple. So they are called radicals because they are group of atoms that have ions, positive or negative. You can have radicals that are positive, something like ammonium ion. It could be positive, it could be negative. They are the ions. So when you hear about ions in chemistry, your mind to go positive charge or negative charge. Okay. Now let's look at what a man says about atoms. A man, John Dalton, he postulated a theory in 1808. We call it Dalton's atomic theory because it's the one that postulated it or proposed it. So this John Dalton proposed the following theory we do call atomic theory, Dalton's atomic theory or atomic theories. Now, he stated 5 theories. He said, number 1, that all atoms are made up of small indivisible particle called atom. All elements are made up of small indivisible particles called atom. Number 2, he said that atoms can neither be created nor destroyed. Listen to this one because there are modifications to this theory now. Number 3, he says that atoms of the same elements are alike in every aspect and differ from atoms of all other elements. Number 4, he says that when atoms combine with other atoms, they do so in simple ratios. Lastly, Dalton says that all chemical changes result from the combination or the separation of atoms. That all chemical changes result either from the combination of atoms or separation of atoms. So these are the 5 theories that was postulated or proposed by this man called Daltons. And as scientists continue, there are some modifications to it because we found out that some of the things that he postulated do not hold water again, are not fully true. Number 1, he said that matter is made up of small indivisible particles called atom. But somehow, we observe that atom can, however, no longer be regarded as indivisible particle. Because of what? Because of a discovery made by a man called Rutherford. He discovered that atom is made up of 3 subparticles, some atomic particles, which are the protons, neutrons, and the electrons. In one of our classes, in our last video, we talked about proton, neutron, and an electron in the issue of mass number and atomic number. So atoms have proton. Inside the atom, we have nucleus. In that nucleus, we have proton and neutron. And in the shell, we have electrons. So it's no longer indivisible. Say that is the smallest indivisible. Of course, inside it, we have subatomic particles. So that is the modification that was made there. Then number 2, he said that atom cannot be created nor destroyed. This particular statement is still acceptable for ordinary chemical reaction. That is the simple truth. But the discovery of radioactivity, some radioactive elements, has shown that atoms can be created or even destroyed. Radioactivity proved this one, partly drawn, that once it comes to radioactive elements, it cannot hold water again. So that is the discovery that was made in the Dalton's atomic theory. Another number 3, he says that the masses of atoms of 2 different elements must differ. Okay? If, however, this is possible for 2 different elements to share the same mass number, such Such atoms are called isobar. Example, carbon, you can see, argon, the mass number of carbon, of calcium is 40, that of argon is 40. But the theory that atoms of the same element are the same, but they are different entirely in all aspects with atoms of another element. But look at this one, the mass number of argon is 40, that of the calcium is 40. We call such a thing isobar. So that is a modification, a discovery that was also made. Then another one is number 4 theory that is said that atoms of different elements can combine a simple whole number and simple ratio, simple whole number ratios to form compound. But this is not true in all cases of complex organic compounds. An issue of the simple ratio is it has to do with just simple compound, organic compound, inorganic compound. But complex organic compound like sucrose or disaccharides, it cannot hold water because C12H22O11, which is disaccharide, it does not hold that particular theory, does not support that particular theory. It's a modification. Then lastly, the theory fails to explain the existence of allotropes. It does not account for differences in properties of charcoal, graphite, diamond, coal, coke, and all of that. Diamond and graphite, all of them, they're all allotropes of carbon. So we also have allotropes of other compounds. So that's number 5 theory that says all chemical changes result from the combination or the separation of atoms does not hold on this one. He failed to explain this one. All right. So far, these are the modifications, Dalton's atomic theory and the modifications. We are going to look at the constituents of atoms. Structure of an atom. Any atom that you see, I said it before, that atoms, inside the atom, we have what we call nucleus. And inside that nucleus, we have what we call protons and neutrons. So we can see at the center of this, we have protons. Protons, they are positively charged. The neutrons, there is no charge on it. Then outside in the orbits, we have electrons. So we use the example of an element. This one in the left is helium. 2 electrons outside, 2 protons inside. Neutron is also there. Then another one here we have also outside the orbit or shell, we have electron. Inside it we have nucleus, and inside that nucleus is where we have these protons and neutrons. That is the structure of atoms. Structure of an atom looks like this. What are we just trying to say? At the center is nucleus. At the shell, we have electron. Okay. Now, an atom is made up of 3 subparticles known as protons, electrons, and neutrons. I've talked about it. As shown, as we see in we saw it in the diagram above. Look at the diagram again, this one. Protons, neutrons, and electrons. Protons and neutrons are inside the nucleus. All right. Their characteristics are summarized in the table below. Protons, electrons, protons, where is it located? Inside the nucleus. Electron is at the atom's shell. Outside nucleus, which is the shells, while neutron is also found in the nucleus. That means proton and neutron is inside the nucleus. In terms of their charges, protons are negatively charged, while electrons are negatively charged. But neutron does not have any charge. It does not have charge. In terms of mass, relative mass, protons is being regarded as 1. That is the mass number of hydrogen. Then electron is negligible, is just 0.005, while that of the neutron is 1. Symbol. P, we use P to represent proton. Electron, we use E minus. Then neutron, we use N to represent it. All right. How are the electrons arranged around the nucleus? Of course, we have stated that electrons are found around the nucleus, outside the nucleus. How are they being arranged there? Electrons are found revolving around the nucleus of an atom in a circular path known as ring. We do call it also orbits. We also call it energy levels or shells. These are the names that you can be hearing one at a time, at a particular point in time. You can hear orbits, around its orbit, around the energy level, around the shell. So they revolve, they move around in a circular path outside the nucleus in such manner. Each shell contains electrons with similar energy. Those with lower energies being nearer to the nucleus. So the shell that is nearer, that is closest to the nucleus, have the lower energy level. The higher you go, the higher the energy of that particular shell. All right, let's take the shells of electrons. Now, this is a sample. We have shell K, L, M, N. First shell is called K shell. Second one is called L shell. Third one, M shell. Fourth one, N shell. It's also being regarded as maybe one, first shell, second shell, third shell, fourth shell. 1, 2, 3, 4. It continues like that, L, N, O, P, just like that. So the arrangement of electrons and the atoms according to the energy level is what we call electronic configuration. Arrangement of these electrons according to their energy level, according to K shell, L shell, M shell, and N shell, or first shell, second shell, third shell, and fourth shell, as the case may be, is what we call electronic configuration. I hope you are following this class vividly clear. Okay, now letters and figures are associated with these orbits. Of course, as we saw in the diagram above, the maximum possible number of electrons that can be accommodated in a shell is given by the formula 2n squared. N mass means the maximum number that each shell can accommodate, meaning that 2n squared, n means the particular shell. If you want to consider the maximum number of the first shell, you use 1, where n x means 2 times 1 times the square of it, where n means the maximum number of electrons, small n is the number of shell. Of course, I've talked about that before. The first shell contains maximum number of electrons, 2 electrons. K shell, which is the second shell, contains the maximum electron of 8 by this 2 times 2 square. M is the third shell, is 2 times 3 square will give us 18 electrons, and so on. So with this formula 2n squared will enable us to know the maximum number a particular shell can accommodate. That is it. Now, these are the first 20 elements. First 20 elements, their symbols, the number of protons or atomic number. Number of protons are the same thing as the atomic number. Then the number of electrons and their distributions in the shell or the electronic configuration, as the case may be. Hydrogen is in K shell, helium is in K shell, lithium is K and L. As you can see, it's run down to calcium, which is the last one. So these are they are being distributed in the shells, K, L, and shell. This is how they are being distributed, and you just look at them critically, and you just learn it. It's very, very simple, and that is it. Okay, now electronic configuration of some, we're going to just use some few as an example. We are not going to talk about the 20 of them. We just need to understand how they are being arranged in the shell. The electronic configuration of some elements are shown below. Hydrogen is only one. It's number one. Atomic number is one. The electron is one. That is K1. We have one. Inside the nucleus is only, inside the proton should also be one. Lithium. Okay, number two, we have lithium. Helium. Helium is two. You can see two electrons out at the outermost shell, and the shell, which is also the same K shell, K2. K2 means that it has two electrons in that K shell, the first shell. Lithium, we have K2L1, means that inside the first shell we have two electrons, second shell we have one electron. That is why we put K2L1. Then neon, which is number 10, atomic number 10, we have K2L8, meaning that the first shell we have two electrons. The second shell, which is K shell, we have 8 electrons. Put together, we have 8 electrons, or 8. Put together, we have 10 electrons, or the 10, which is the atomic number of neon. We have sodium, K2L8M1, meaning that the first shell it contains 2, second one it contains 8, third one it contains 1. Another one is argon. Argon is 18. We have K2L8M8. As you can see, the diagram is telling you the number of electrons that it contains. Altogether is 18. The last one is calcium. We have here K2L8M8N2. That is calcium, and that is the diagram. It depends on the way you want to draw the diagram. What is important there is to get the number of maximum electron that it contains all together. Okay, what is now mass number? What is mass number? Because for the fact that we are talking about issue of proton and neutron, electron, we should understand what atomic number is and the mass number is. So what is atomic number? When you hear about atomic number, it's telling you about the number of protons in the atom of that particular element. The number of protons are the same to the number of atomic number. Is the number of protons that determines the atomic number. Simple. The atomic number of an element is a whole number and is being designated as Z. We use Z to represent atomic number. However, the atomic number of all elements of any particular element is equal to the number of electrons. So in a neutral atom, the number of protons must be equal to the number of electrons. In a normal atom, in a neutral atom, it must be equal to the number of electrons. Since protons are positively charged and electrons are negatively charged, so two of them must have to be equal in order to cancel the reaction, positive and negative, so that they will attract and give it a neutral atom. Positive and negative must have to be equal for such atom to be a neutral atom. All right, all atoms of a particular element have the same number of protons in the nuclei, in their nuclei. Nuclei is a plural form of nucleus. When you have more than one atoms of a particular element, of course, all the protons must be the same. They must have the same atomic number. No two elements have the same atomic number or the same number of protons in the atom. As we saw in the chart we just saw passed above, we saw that with our first 20 elements, you see, number 1 is only hydrogen that is number 1, that has the atomic number. Number 2 is only helium. It's only calcium that is 20 atomic number, I mean atomic number. So in terms of mass number, we can have two, like argon and the calcium have the same 40-40, but the issue of atomic number, no two atoms have the same atomic number or the same proton number. Know it. So you just need to learn the first 20 elements or learn all the elements in the periodic table there, because their atomic number are peculiar, their proton numbers are usually for them, and no two elements replicate one. Okay, we have done that, and what now is now mass number. Mass number is the sum of the protons and neutrons in the atom of an element. or in the nucleus of an element. The number of protons and neutrons inside the element, inside the nucleus, is what we call mass number. Mass number is inside, they are inside the nucleus. So summation of the two is what gives us what mass number is. And mostly we represent it with a letter A. We represent an atomic number with letter Z, represent mass number as letter A. All right, mass number equal to the number of protons plus neutron. If that is the case, P is proton, N is neutron. A means that A is P plus N, where P is proton, N is neutron, or the number of proton, number of neutron can be done this way by making N the subject of formula. Mass number minus atomic number gives you neutron number. So look at the symbol and it will give you what I'm just trying to say. Symbol of an element, we are using X as an example. Mass number should be on top of that symbol and the atomic number should be down, Z, as we said. Protons and neutrons are all inside that mass number, while atomic number is of protons alone, with the number of protons. All right, that is it. With this now, I believe you can differentiate between mass number and atomic number. Very easy. For further discussion and inquiry, do well to get across to me. Do well to get across to me through my phone line, +234 08 655 732, +234 08 655 73229, or send me an email through my email address at christo116@gmail.com. And remember to give us, to make your comments, get back to us on this particular video and how you like it, or the input, make your input on it. Thank you for being part of this particular class, and remain blessed, and we look up to the next class. Thank you.